Hello, my name is Greg Valentine. I am the SVP of Solution Engineering at Industrial Defender, and today I just wanted to share some of the features that are built into the version 8.0 of Industrial Defender solution. Specifically, I'm going to be focusing on asset management, our change detection capabilities, our vulnerability management solution, and our compliance and non-compliance reporting capabilities. So to start with, let's begin just by giving you a view of what is included inside of our demo environment. And if I zoom in here, this will give you an idea of what our architecture for this specific demo instance is set up as. You can see at the very top here, this is our central manager. This is basically our server. This is where the user interface is. This is actually the device that I'm logged into right now. This is also where the database sits. This is where the reports are executed, policies are executed, change detection, etc., etc. But our central manager is not where the data gets collected from. Our collection of information is done by one or more, in this case, of our IDCs or Industrial Defender collectors. So in this specific instance, I have an IDC for one site, and you can see the different devices below that are being monitored by this particular IDC. And I have another IDC for a completely different location, monitoring different devices for that other location. Both of our IDCs collect the data, the configuration data of those devices, but is also monitoring the network activity on those different subnets. The data collected then gets passed to another IDC, and you could go on and on with this. You could go from one IDC to another IDC to another IDC to another IDC until ultimately all of that data ends up in our central manager, where it gets processed for reporting purposes, etc. Okay, so that hopefully gives you an idea of what the makeup of our demo environment looks like. Now for the homepage, our homepage is now focusing on risk. So at a very high level, we are telling you that there are 27 devices. So that bottom row from the topology map has 27 different devices. So there are 27 devices. You can see at a very high level what their risk profiles look like. I have 3 categorized in high risk, 24 medium, and 0 in low risk assessments today. But if you want to get more specific, then you can scroll down and see the different specific attributes that we use to then calculate that higher up number. So vulnerabilities and patches are part of the risk assessment calculation. Security event information is also calculated in part of the risk assessment, and baseline exceptions. Exceptions in our vernacular just means changes that we've detected. So vulnerabilities, you can see the number of vulnerabilities is going to be used when we're calculating risk values. The CVSS scores of those vulnerabilities are also going to be used in the formula when we calculate the risk values for the different devices as well. And over on the left-hand side, this gives you different ways that you can basically look at subsets. So instead of 27, maybe I just want to look at one specific location, and now I'm looking only at 9 devices. Or maybe I want to look at 2 locations, and now I'm looking at 20 different devices. So lots of different ways to get to the information that you want to get to. Now, from an asset management perspective, let's focus on the devices themselves. So this is really just a table view of the devices that were at the very bottom row of that number topology. And I'll just highlight some of the interesting pieces that to pay attention to. Certainly the asset name and the location are important, but collection profile is very important too. The collection profile is our way of telling you how we are collecting the data. So for these two devices at top, these two PLCs, we are using the NERC CIP OT protocol to collect configuration data of those two PLCs. If there is a blank value in here, that means that we're leveraging one of our agents to collect the data for that device. And again, we have agent software for Windows and Linux and Unix and even Solaris. The next one, we're using the BACnet OT protocol to collect data from the devices. Then below it, for Dragos Site Store and our firewalls, we're using the SSH IT protocol, really, instead of an OT protocol. So we're actually programmatically logging in via SSH from our IDC to the firewall, to the Dragos Site Store, in order to then collect the configuration data. All of the configuration data that we collect, by default, we do it once per day. So one time each day we log in or we send a message via the OT protocol to the device to then collect that information. Once we collect that information, we then compare that data with the baseline for that particular device. Each device has its own unique baseline, the way that Industrial Defender handles change detection. And if there are any differences, we call those differences exceptions, and we let you know about them. So let's spend a couple of minutes just looking at what kind of data we are collecting. So for these PLCs that we're using the OT protocol NERC CIP to collect, if I just look at the most recent data collection, let me explain what this UI is. On the left-hand side, these are the different categories that we define to normalize all the data across all of the wildly different device types that we're capable of monitoring. So PLCs are very different from firewalls, which are very different from engineering workstations, which are very different from routers, which are very different from X and Y and Z, right? So very different types of devices that we can monitor and collect this data from, but we display that configuration data under these categories that you see on the left-hand side. Now, a PLC has no idea what a firewall rule is, of course. So for a PLC, this is going to be blank. You don't have firewall rules on a PLC. But for asset details, this is where you're going to store the most amount of information. So you can see we have property names in here. We have the values for each property. And on the right-hand side, you can see what time we collected all of this data. So this was all collected at 1 o'clock this morning. You can see some interesting pieces in here, like what kind of a PLC is it? It's a Rockwell Allen Bradley PLC, 1756. It does understand the ENIP protocol. And then as I scroll down, you can see additional details. Now, what's important to note is that every single one of these properties or attributes is going to be monitored and checked for change. So you can see in here, there's a lot of true-false values. If this true value here becomes a false value tomorrow, that would show up as an exception in our world, in our user interface. Another thing to pay attention to is that we are displaying the different slots that are basically stacked up. So these are the different modules stacked against the backplane of that PLC. And you can see each module has its own unique set of values as well. Under the software installed, this is where we log and display the firmware information for your OT devices. This is also where we display the firmware details of your networking devices like your switches and firewalls, etc. For your Windows and Linux devices, this is where we actually show your application information. But you can see in here the device, the firmware version. You can also see for each module attached to that PLC backplane, each module could potentially have a different firmware version as well, and we display that. Now, let me show you a couple of other types of devices. Let me show you a Windows device. So we have the same categories on the left-hand side that we did on the PLC and we would on the firewall, etc. But the details, the properties are very different. So in the details or the properties, you can see very Windows-specific stuff like processor, memory, BIOS, SMBIOS, file system details. And then we get to the Windows event log. We are able to pull out certain values from our logs on any device type that has a text-based log. We also can pull out registry key information like what's the maximum password age, what's the minimum password length requirement for a password, etc. Then down below you can see we certainly tell you what the operating system is, Windows 10 Pro in this case. And this is really important. It's very challenging if you're just passively watching the network traffic to tell the difference between Windows 10 and Windows 7. They look practically identical. We can tell you not only that this is Windows 10, but we actually know it's Windows 10 Pro. We know the version or the flavor of Windows 10. And in fact, we even know the build number of the Windows operating system itself. And this is critical when it comes to vulnerabilities. The more accurate you can be and the more specific you can be, then the fewer false positives you have to worry about later on. For software, as I said earlier, this is where all the applications that are installed show up. So you see the app name, the versions of the app, who the vendor is, and when was that application installed. It is Windows, so we have patches that are listed, including service packs, and when the patches were installed. Ports and services, this shows you all the open ports on that device. Is it TCP or is it UDP? Is it IP4 or IP6? And what process is holding open the port? It's Windows, so most of the time it's going to be service host, which manages your services. But we can tell you the child process that's being managed by service host. So terminal server being managed by service host is holding open port 3389. Firewall rules. If the Windows system has the firewall enabled, then we will grab all your firewall rules, tell you which rules are enabled, which ones are disabled, monitor these for changes as well. We can also tell you all the local user accounts on that particular device and their group memberships. So if you have an existing user that is just a member of the user group and then gets elevated to be a local admin group, then that shows up as a change as well. And then you can see we also calculate or display the when was the last time the password has been changed on those different devices as well, or user accounts as well. And are the users enabled or disabled? Files are interesting. Files with the agent, you can tell our solution that you want to monitor any file that you want, or a few files, like project files, or maybe operating system configuration files that you want to monitor for change. Kind of a file integrity monitoring capability. You can add those to our solution as well. And then last but not least are the device interfaces. These are the network cards on that device. And I have several network cards, but only one of them is actually configured and running. We separate IP4 from IP6. We just treat them separately. So these two entries are actually one physical network card, as you can tell by the MAC address. All right, so let me show you just really quickly. I'll show you a firewall. Again, same categories on the left-hand side, very different details inside of the categories. You can see the SSH information for that particular firewall, telnet details. You can see that we're pulling data from the log on that firewall as well, and some network settings. Under software, this is where we log the firmware versions, if you recall. So firmware for your network devices and your OT devices, application data for your Windows and Linux systems. There are no patches. You just update the firmware for network device. These are the ports that are open on that firewall, and you can see what process is holding open each of those ports. firewall rules. It is a firewall, so we do grab the firewall rules. Don't hate me. This is just a demo firewall rule. I don't have very many rules in here, but I just created a couple just to demonstrate what those look like, what user accounts are on that firewall, what their privilege level is, are they enabled or not. Interesting for network devices, switches, firewalls, etc., we automatically will download a copy of the config file. For your Cisco devices, we'll download the saved config or the running config. For your firewalls, we'll download the firewall.conf file. So every single day since we started monitoring that device, we have what amounts to a backup copy of your config file for those network devices. So you can go back to yesterday, 3 days ago, 3 weeks ago, and download the config file for any of your network devices. And last but not least, the networking cards on those devices and which ones are set up and enabled and which ones are not. Now, I'm going to kind of highlight a couple of Schweitzer blue box type devices because I find these very interesting. So if you have any Schweitzer RTACs, gateways, relays, then this may be particular interest to you. So we have an SEL 3530, which is an RTAC. We're using HTTPS to collect the data from this device. So if I look at the collected data, all we're doing is we're logging into the web interface on that device to be able to get the firmware, the checksum, serial number, part number, etc. So just to show you the other bits and pieces, here's the firmware for it. I think that there obviously is no firewall rules. These are the user accounts on it. These are the network card network interfaces for that particular RTAC. And if I look down below, you can see the IP address for that particular RTAC. So if I want to, I can just log into the UI for that particular Schweitzer device. And this is what we're doing every single day programmatically to collect this information. So here's the checksum, here's the project ID, here's the firmware version for that RTAC. And that's all that we're doing in order to collect the data for that 3530. And the same thing for the 3620, which is a gateway. Now, what is particularly interesting, I find, is the 351S. And the reason I find this interesting is it's setting up and connecting to this relay, leveraging a jump box, what amounts to what we call a jump connection. What we're doing to connect and collect this data from this relay is we are, via the IP network, SSHing to the RTAC, the 3530, and then from the 3530, using that as a jump box to then connect through the serial cable to the relay behind the RTAC. So all of this data we're collecting to monitor this RTAC, we're connecting through the serial cable connection. So that is a possibility and pretty straightforward process for us to do to collect the data from all the relays behind your RTACs, for example, or any gateways if you have gateways set up. Very powerful way of monitoring your relays, even though they're not on the IP network. Okay, so that's the asset management. Hopefully I answered all of your questions. I want to move over pretty quickly to our vulnerability management piece, because I find this really interesting. We do vulnerability management a little bit differently from anybody else. We're not sweeping the network, looking for open ports on devices and knocking on ports or anything like that. Instead, what we're doing is we're looking at the data that we're already collecting. So if you think about it, we already have all the firmware for your network devices and your OT devices. We already have all the application versions that are on all of your Windows and Linux devices. We already know specific operating systems on your devices. So what we do is we take that information and run that against the standard locations, the National Vulnerability Database, CISA to get you any CISA alerts or any CISA advisories. We also can check against some certain OEMs to get you specific details on OEM vulnerabilities. And then what you get is really just a straight list of what all the vulnerabilities, and we have different ways of viewing this information. So you see the CVEs on the left, you see the number of devices that each CVE has, you see the CVSS score, and you can sort these just by clicking on the column header. Pretty straightforward way of doing it. And then, are there any patches available for those vulnerabilities? Yes or no? Any CISA advisories or alerts, etc. So if you want to look at any of this information, you can just click on the details, and we'll give you all that interesting information that we've collected about that CVE and all the standard CVE, CVSS metrics. As far as the assets, we'll tell you which devices have that vulnerability and where each one of those devices are located. Is it a vulnerability in an application? No, it's a vulnerability in several operating systems, though, instead. And as far as patches, it's going to have to calculate this because there are certain patches that circumvent, that include other patches, et cetera, et cetera. So it's going through the process of figuring out which of the patches would apply specifically to this set of CVEs. And then last but not least, and there you go, you can see all the CVE, all the KB patches that could or would mitigate this particular vulnerability. And then last but not least, any advisories or alert, but there aren't any for that one. Now, let's just think for a minute. If tomorrow was the beginning of a maintenance period, and I deploy one of those patches that you just saw on the list that mitigates that vulnerability, once you deploy that patch, if you remember, that's part of our data collection process. We automatically, every single day, collect, and we'll see that you deployed that patch the next time we run. So we will see that you deployed that patch. We already know that that patch mitigates that vulnerability. So we will automatically remove that vulnerability from any device that you deployed that patch to that we are monitoring. And that kind of keeps everything automatic and up to date. And that's great. Now what we ask our customers to do is to update this about every 30 days because we don't know about new vulnerabilities that are coming out tomorrow because they haven't been announced yet. So do it about every 30 days, update every 30 days or so, and you'll be current basically because everything in the past is going to automatically keep up to date. We just want to know about future vulnerabilities that we don't know about today. The rest of these tabs are just showing you different ways of pivoting the same data. So right now we're looking at all the different devices and how many vulnerabilities each device has. You can break it down by applications. You can break it down by operating systems. And last but not least, you can see all the CISA advisories and alerts that have been announced and how many devices or assets fall under those particular advisories, etc. And you can see the information here. And if you have internet connection where you happen to be viewing this information, you can click on the publication and it'll take you to the CISA publication, assuming it's up and running. I'll let that keep running just in case. And then you can see all the vulnerabilities that apply to that particular publication and which devices have that publication as well. And here's that CISA publication. Excuse me. All right. So that's vulnerabilities. Last but not least, let me show you our reporting capability. So our reporting is very, very thorough. But honestly, the reason that it's very, very thorough is because the data that we're automatically collecting every single day is so very, very thorough. We have so much data to play with. That is what brings the power of our reporting capabilities to bear. So you can see we have our standard reporting capability, including vulnerability reports if you want to look at any of our vulnerabilities in a reporting standard. But the rest of these tabs are really different compliance frameworks that we have incorporated into the product. You get all of these automatically by default. You don't have to pay for NERC CIP and then have to pay for Saudi Arabia's OTCC framework. You get them all automatically because it's interesting. NERC CIP 5, for example. A lot of our customers are leveraging our NERC CIP 5 capability for surviving an audit, basically, because we have all of that interesting data. But we also give you AESCSF, which is Australia's version of NERC CIP that's coming online now. So if you happen to be in the electric utility space and you want to see how do you compare with Australia's way of looking at cybersecurity for their electric utilities domain, we give you that information as well. So a lot of information in here, including NIST CSF, which is one of those standards that everybody leverages, basically. And you can see all the different elements where we can give you reports for. So if you find something in here that's interesting, you can come in and run one of our reports or subscribe to a report. Now, running a report is straightforward. You tell our solution what devices or sets of devices you want to run the report against and what time frame, and it gives you the answer in PDF or spreadsheet or Word or HTML output. A subscription is very similar, but you're basically telling the solution, I want this report to run on a regular cadence every other Tuesday or once a quarter. And I want it to run on these devices or groups of devices. And I want to get the data in a HTML output or a PDF or what have you. All of those are included in the subscription. And then that report will be emailed to you automatically whenever it runs. And then when the report finishes building, you can see the reports in our report center. And the report center, this is basically a library of reports that have already been run in the past, and you can pull it up at any given time, and or you could re-execute any of these reports at a given time as well. So I could come in here and look at the vulnerability exception by asset PDF and download it if I wanted to, and then bring the results up, and I can see in here, this is just a very high level overview. We always give you a description of what the report is about, and then you can see what devices were selected for this particular report, and then I can see the actual nuts and bolts of the report below. You can see the asset name, location, IP address, etc., and how many vulnerabilities each device happens to have. So that's our reporting capability. Last but not least, let me circle back to the asset managed piece and talk about our change detection. I've already explained how that takes place. Every day we do the data collection, and we then compare that with the baseline for that particular device. If I look, I can see here in this column whether or not an exception exists. So a green check mark means basically nothing has changed. A red exclamation means something is different, but I don't know what. If I click in that exclamation cell, then it's going to show me the exceptions for that particular device. Now, across the top, these are the different categories. If you remember the categories, I don't have any changes in asset details, but I do in software. And I can see that the application and firmware bootloader has been changed. I also see that ports and services, there are 2 new ports that are enabled on that particular device. If I want, I can also see on another device, like this Windows system. This one I have Microsoft OneDrive. Basically, this one has been removed and this one has been added, which basically just means that application has been upgraded. One version's been removed and one version's been added. So that's the granular level that we're able to get at to show you every little change that has taken place. If it's okay, If you need to review and approve those, no problem. That's part of our update process. You can also tell our solution you just want to automatically update these changes and accept these changes. If you just want the changes to be automatically added so you don't have to worry about the red exclamation point, we can do that as well. Completely up to you. I hope that makes sense, and that gives you a good overview of our version 8 solution of Industrial Defender. There's many more elements to the product, as you can see up at the top. I've only talked about a couple of these menu options. Please stay tuned. There will be more videos to come. Thank you very much, and have a great day.